this example. We have x to the fourth plus y to the fourth equals 16. Okay, and what we need to do is find y double prime, the second derivative. So double prime, double the pleasure here. So let's see how this works out, if indeed it gives us pleasure or pain. I suspect the latter rather than the former, but who knows. Now, one thing that I can do, and I did it earlier, I don't have to break down d dx of the left side equal d dx of the right side, because essentially this is a relation. I can say I can take the derivative of the whole thing, like so. Okay? There is no rule against it. You can differentiate the whole equation. Okay? Remember, this is with respect to x. So let's see. The first term, it's easy. It's 4x cubed. The next term, we first differentiate with respect to y, and then we'll do dy dx. So we have 4y cubed times the derivative dy dx, and then the derivative of 16 is, of course, 0. Okay? Now we can divide everything by 4, right? And move to the other side, and you end up having dy dx equals negative x cubed divided by y cubed. Or, if you want, you can write it x over y cubed, like so. This is the first derivative. Okay, now I'm looking at the second derivative, and I can either do explicit differentiation. Well, it's not going to be, because I have y prime here. We can do it in two different ways, but I can go back right here. You see this thing? And I can go ahead and continue to differentiate. Or I can differentiate it without the 4. Okay? So I can write if 4x cubed plus 4y cubed and dy dx, I'm going to go back to the prime notation, equals 0. I can write it as x cubed plus y cubed y prime equals 0, and I'll do d dx of this thing, like so. Again, this is not the only way to do it, but it's one of the ways to do it, and it's not bad. It's not a bad way at that. So let's see what happens now when we do the second, when differentiate one more time. You'll find out that we end up having both y prime and y double prime in the mix. Let's see. We have 3x squared, and here we have a product rule, right? So we have 3y squared y prime times y prime, okay, plus y cubed times y double prime. Again, by the product rule. But remember, we're differentiating with respect to x. And then the derivative of 0 remains 0. Does not change. Now, remember, what we're trying to do, we're trying to solve for y double prime. Right? But before that, we need to deal with y prime squared. So let's see. We have 3x squared plus 3 y squared y prime squared plus y cubed times y double prime equals 0. Y prime is x, negative x cubed over y cubed. You see that from here? Or from here. So we're going to substitute at this point. We're going to say 3x squared plus 3y squared times, instead of y prime squared, I'm going to put negative x cubed over y cubed, and I square everything here. And then I have y cubed times y double prime equals 0. So let's see where we stand right now. we have 3x squared plus, or minus rather, we have 3y squared times x to the 6 divided by y to the 6. And actually, we still have plus because negative squared is positive. So we have plus, we didn't lose it, plus y cubed times y prime equals 0. We have a little bit of simplification here. We do it on the next page. So at this point we have 3x squared plus 3x to the 6 over y to the 4th, right? Plus y cubed times y double prime equals 0. I want to eliminate the denominator here. So I'm going to go ahead and multiply everything by y to the 4th. Okay? So I don't have to deal with fractions. So I have 3x squared times y to the 4th plus 3x to the 6th plus y to the 7th y double prime equals 0. And now I'm ready to solve because I have everything. The only thing I need to do is isolate y double prime. So let's see, what is y double prime? It will be, these two guys are negative, right? So we have negative 3x squared y to the 4th minus 3x to the 6th, and we divide everything by y to the 7. But I can simplify. Actually, I have a major league simplification here. Can anyone see the major league simplification? Okay, what shall I do with it? Factor it? Okay, so say it in a complete sentence. And what's left? Minus
y squared minus x.
Disagree.
Plus x.
X to the 4th. And what else?
Y to the 4th.
Plus y to the 4th. Good. Now, what's the value in writing it like so? What can I do next? Substitute with 16. Very good, because remember, the original equation was x to the 4th plus y to the 4th was 16. So we end up having a negative 3x squared times 16 over y to the 7, and eventually we end up having negative 48 x squared over y to the 7th. So what started as a horrible result, we end up y double prime. We have a nice, compact, elegant solution.